Today we do serious data analysis. Here I present you Barney the dinosaur's eyes that have popped out of his head. And we ask tough questions. Doesn't this look like jellyfish at a cocktail party? Hey folks, welcome. So this is the third video in our series on building a Lego optimization application. And rock and roll, this is the unboxing data video, which means it's a bit like having a new Lego set. Right? You can hear all the parts inside. You need to go find a table large enough to sprawl all the parts over. And get busy. Right now there's two ways where you can proceed from that point. You could follow the instructions that come from the awesome Lego company and build the thing that's intended. Or, and this is the magic, you could do whatever you want. You can pick out the pieces that you think might be useful for something else and start building something of your own imagination. It turns out, if you're building an optimization model, kind of same deal, right? We as optimization modelers can go to the literature, find formulations that seem like they're amenable to our particular problem domain and get cracking, implementing those. We know we're always going to change them, customize them, fit them, and so on. But it's nice to start with something, except when it isn't. And I think that often that second method gets slightly short shrift in our community. I think that it's totally possible to look at data, look at these Lego bricks out on the table, shake the data model around, really get so familiar with it that from the data model, an optimization model starts to pop out at us, right? So we need this data. The Rebrickable team make available to the world all of the data. Thank you so much, Rebrickable. Go ahead, anyone who's interested, and download every single one of these CSVs. Rebrickable team, thank you, we love you. We're also gonna grab this handy schema diagram. We're gonna take it and plonk it into our whiteboard from last time. We're gonna make a good old mess in our whiteboard. And spoiler alert, we go through the process of shaking this data around until we identify the subset of entities in our data that is for sure required in our optimization model. And how that looks on paper then, I'm using Ample. You can use any language tool library that you like, but these optimization models, roughly speaking, have 5 components to them, right? We've got some sets, some parameters, some variables, an objective or objectives, and some constraints. And at the end of today, we will have our sets firmly in place. We'll have the initial objective, and because it invokes one variable, we get a variable as a bonus. Good, let's get organized. To the project folder from our GitHub repository, I've simply added a data folder, a CSV subfolder in that data folder, and into that I've plonked all of the CSVs we just downloaded. Now we want to do a tiny bit of housekeeping on that schema. So we're unboxing our data, and we specifically want to discern the entities from relationships in our schema, and also to add any fields that might not be shown. So here is our schema diagram, and those entity tables are the pink cube marked tables here, right? And then the green little linkety icons, let those represent our junction tables. Great. Next, these little orange bits, these 5 instances of missing fields I've identified in the CSVs just by poking around. No big deal, but in our case, the image URLs are so rich a source of awesomeness about this data. I mean, let's just take a look. Let's go to our sets table and see this image URL unexpectedly appearing here because it was not on our schema. If we go to our browser and chuck that in there, ha! Look at that. This is awesome. A Lego set from 1965. It's very clear that the Lego company still hadn't quite made its mind up about the shape of at least gears. I've never seen Lego gears like this. Also, these multicolor stripes that were quite prominent as a branding thing on many of the early boxes, they remind me of the television test cards as a kid in the 90s when there was literally nothing on TV, like no actual programming. They'd have this thing that went, yeah, that thing. So great, these images, indispensable. What else was not on the schema? Well, poking around further in the CSVs, I found a part material field on the parts table, which simply says, hey, what are parts made of? It turns out there's 7 things that Lego parts can be made of, like plastic, flexible plastic, rubber, metal, cloth, foam, and I must be forgetting something, paper, I guess. And then elements. Look, we're gonna just take an opportunity to nix this entire elements table here. We are not gonna be using elements. So elements are a merge of the parts and colors entities, and they're a courtesy to many people in the Lego community who do want to find Lego parts by element ID. And there's actually a fantastic article on the Rebrickable help guide with some background and history on the various numbering schemes in the Lego universe. An awesome read. It places the element ID into context. But for our purposes, we absolutely want to keep parts and colors separate. So no elements for us. So we've done a good job cleaning up our schema, and we now need an objective to guide our further exploration of this data set. So if you're starting an optimization project and you have no clue about what your objective is, ask your boss and they'll tell you, oh, wait, you need a number that you're going to maximize or minimize, right? Okay, money. Maximize money. So you'll always know what objective you're going into a project with. In our case, we imagine an initial objective thus. In the first video, the problem description video, I go to town explaining the nature of the application we want to build. But super recap is we are building an optimization model that facilitates a search over the possible universe of buildable Lego sets that can be built from one user's part. We are in fact entirely re-implementing option for option the build search feature on the Rebrickable website. Except the twist is the results that we get at the end are all guaranteed buildable at the same time. That's what we're building. And since we're going to conduct the search of that space of buildable sets via a mixed integer linear program, our objective sensibly could be something like, hey, find the maximum number of currently buildable sets, all right? Find the maximum number of sets concurrently buildable from my Lego parts. So what we're maximizing is literally just the quantity, the number of buildable sets. I've put here into brackets from my Lego parts because using constraints and who knows what other sensible variable bounds and things, we will affect the machinery of, hey, make sure that we actually have the parts in the inventory. Now, maximizing the number of buildable sets is going to have the effect of returning very, very small part quantity sets, right? Tiny sets. But even that we can hedge against with some sensible constraints. Maximize the number of concurrently buildable sets, but be sure they're over some minimum part number, some bound that we implement, right? So this is not a bad objective, and we walk into our data from the perspective of this objective. And we begin to explore. All right, now, what does exploration entail? We want to begin at our objective entities, which are what? They're sets and parts, the two things that we invoke in our objective, right? And then we want to explore the nature of relationships. Whatever relates to sets and to parts, and then at some point parts will relate to sets themselves, right? We want to explore the nature of those relationships because it's the nature that matters. We already have a fantastic map of the topology of relationships. It's our relational schema diagram, right? But we want to understand whether the relationships are relationships of aggregation, composition, association. This is a small subset of the UML, the Unified Modeling Language lexicon of relationship types. There are many others, but for our cases, we only really need three: aggregation, composition, and association. And this thing here, multiplicity, is like a way of saying, hey, this thing here that relates to this thing here, many of this thing can relate to just one of this thing, or many to many, or one to one, right? So do we use this notation to denote the multiplicity of a given relationship? And this is all we need. And we basically, the task ahead of us is just to get really familiar with the entities in these different tables and how they relate to one another by way of, is this a relationship of aggregation, composition, association? So, let's get practical. Let's just like start at themes. I know we said we'd start at sets and parts, so we'll get to them very quickly because themes is just next door. Start at themes. I've taken the theme CSV, dragged it into this place here called GraphXR. This is a really powerful tool for exploratory data analysis and other things. And the way in which we're using it, we literally just drag CSVs over this browser tab, and then boom, they're rendered in this three-dimensional space. And I gotta tell you, like, to me, this was the insight that the Z-axis, the extra dimension here, the three-dimensionality of this place really gives you the power. I love GraphXR because I haven't found another tool that has a three-dimensional exploration of data in this way, and I'm geeking out at it. I have no formal affiliation with the folks over at Kineviz, who are the makers of GraphXR. Ooh, fancy new front page, guys. But I do know some of the people there. Shout out to Sony Green. Shout out to Wei. Sony Green over at Kineviz is one of the nicest human beings you'll ever meet. I miss you, Sony. We haven't spoken in a while. They got other products here. I wish I could tell you folks what SiteXR and SeekerXR do. I have no idea. But GraphXR absolutely is awesome, and you're going to get a face full of it now. So If I wanted to relate themes to their parents, because we know that themes are a hierarchy. How do we know that? On the Rebrickable website, there's this great find sets interface, and you can go to show advanced options and you can say themes. And you can see that, you got these themes like agents, all right? You search for agents, and then we've got, ooh, this looks fancy, aerial defense unit, hurricane heist. This looks cool. But agents have also got a sub-theme called ultra agents, indicated here by this little arrow. It's an ultra agent. So I guess there are agents even better than agents, and there are ultra agents here, right? So this admits of a hierarchy, but if we wanted to manually get familiar with that hierarchy, we would have to go to our CSV. I'm opening up my CSVs in a text editor, Sublime Text. I love Sublime Text because it's so fast, right? Themes, the first theme is Technic, and it has an ID of 1, a name of Technic, and it has no parent ID, right? But immediately below it are some themes that do have a parent ID of 1, right, of Technic. So if we looked for those, we'd see here, yeah, we've got about 8 children on the Technic Lego theme, which is cool. But if we wanted to ask sophisticated questions like, can children have children? Have children have children? Can some themes sit alone, like without any relationship to parents or kids? Yeah, that would be quite an interesting manual analysis, and we could use a bunch of Python data analysis packages for that. There's a lot of ways that we can get to. This is an awesome way. So check it out. Themes. I'm just going to relate themes to their parents, and I'm going to name that relationship something sophisticated like child of. This theme is a child of that theme. Yep, look at that. Boom. We can already tell the answer. Yes, Speed Racer is a theme on its own. Power Miners, right? Clickets. These are just singular themes, great. We have the answer to the question, do themes have kids that have kids that have kids? Is the hierarchy multi-level or not? Well, I'm doing it the lazy way. I'm just dragging like what look like parent themes out. See? Boom. Okay. That is just a drag. So far, no one seems to have, kids that have kids, but I can just stay and be persistent here, right? Doesn't this look like jellyfish at a cocktail party, right? Here, Duplo. If I drag this out, come on, Duplo, come on, don't be so heavy. Boom. Okay, look at that. Duplo is definitely a parent theme for a whole bunch of children who then some of them have had children of their own, right? We can tell that here. Good. We can do whatever we want. We can delete certain of these nodes or all of them. We're not affecting the underlying CSVs. So, well, let's get back to our task at hand, right? We wanted to figure out the nature of the relationship. In fact, what's the first one we're working on? Themes to themes. There is this little squiggle here on our schema diagram that says, hey, themes are related to themes somehow. And now we have a very good idea of what that relationship is like. This is the kind of remapping of our relational schema diagram into what is a UML entity relationship diagram. And obviously one relates to how stuff is actually stored, flattened into a database and what tables represent what. This is more of a philosophical conversation about the connection of things to things. But importantly, we're starting to use this notation here, right? And we can see that themes, let's say, let's do this. Let's go to the Lord of the Rings, the best theme in the universe of Lego themes. Here it is. The Lord of the Rings theme is this one here. Thank you so much for that, right? Now, if I want to get that one and just pull it out here, boom. And let's do something like this. I'll highlight all of them, and then I'll invert the selection so everything else is highlighted, and I just delete everything else. Now we are left with just The Hobbit and The Lord of the Rings. And this is very useful. So we can sort of begin a mapping from here, roughly speaking, okay? And that's what we've begun here. So we can see that The Lord of the Rings is a child theme of The Hobbit and The Lord of the Rings. It aggregates up into that, meaning if you removed any thing from an aggregation, the aggregation still makes sense, right? If you have a box in your basement called clothes to give away to charity, right? And you remove some of the clothes, you change your mind about that, ooh, actually I want to keep this scarf or something like that, the box is still a coherent collection of the other things that you want to, give to charity. Not so with relationships of composition, right? Parts relate to sets via these things called inventories, and inventories are essentially just a version of a set, right? Sometimes the Lego company has the need to change some little parts. So check this out, okay? We are here in the Mines of Moria, and this set has been issued, some time ago, probably soon after the movies came out. During that time, the Lego company, they had an initial inventory on which all of these hundreds of different parts that make up this set were listed. And then they decided to change something about that inventory later on. You can see that this is version 1 up here, and then this is version 2. And what's the difference? Well, they're almost exactly the same. This is just a little notation I'm using. These first 8 pieces and then the ... represents the 100 or so many different types of parts in this. And then this little last bit here, these last 4 items are different. If you take a look at the differences between version 1 and 2, you see that version 1 has got kind of a more square corner on this part 4865A. They made it more round and smooth and genteel, right? 4865B. So, ditto for the other parts. There are some minor mold, it looks like, differences on these other parts. So Lego had a reason to do that. Maybe customer feedback told them that these parts were breaking or hurting people's fingers or just not looking good or whatever. So they made the change. And that actually happens quite a lot. So back to composition. Parts, they compose the inventory. Unlike aggregation, where you can take something out of the aggregation and the aggregation still makes sense. If you took this part, this cheese slope, out, the whole Minds of Moria, the vision of the designers is no longer coherent, right? If you removed this cave troll's head as a part, and just say, okay, that's the one part you don't get, then something's obviously missing here, right? The composition is broken. It is now incomplete. And that matters from a modeling perspective. When we come to build this optimization model, constraint for constraint, that distinction between aggregation and composition is going to be really important. Okay, so now get to sets and say, well, let's import sets. Boom. Okay, sets are this lovely cosmos of red things. Isn't this cool? This looks like that screensaver on Windows in the 90s, right? If you just thought about it like I did, we're of the same generation. Hi. Okay, so great. So we have 22,000 sets as dots here. And our little 3 themes there. Let's create an association. I'm going to link sets to themes, and let's just call that something sophisticated like in theme. Right? We're creating a relationship. There it is. Boom. Okay, nice. Okay, so now we kind of need to get rid of all the sets that are dirtying up the thing, because we really only care about the Lord of the Rings. And this is getting a little messy, so I'm just going to right click and say select all the floating nodes, the ones not connected to any other stuff, and boom, they're gone. Okay, now check it out. Now we've got a little family here, right? The Hobbit, the Lord of the Rings. Let's organize this nicely. I don't know, we'll lay them out as a ring, let's say. Doesn't it look like a space station? You know what would really make it look like a space station? Is if we grab the next thing that connects to sets. All right, let's grab our inventories here and shovel them over here, and now we have some stars. Isn't this nice? Now we are a space station in the beautiful cosmos. I love this. Okay, great. So obviously, some of these inventories relate to our sets, but not all of them. You know where this is going, same deal. So here I present you with Barney the dinosaur's eyes that have popped out of his head. This is just an arbitrary arrangement. Lord of the Rings on top, Hobbit down below. Red things are our sets. Then we've got our inventories here, the little blue circles of inventories. The part little clouds, these little pink puffety things are all the parts. There's so many parts it didn't even make sense to arrange them into a circle. The circle would be massive. Yellow stuff is our minifigs. We've got all of our image URLs should we want to take a look. Look at that part, right? Let's take a look at a little image URL from a set somewhere. Ooh, fancy man. This is a really great way to engage with the data on a granular level, right? And we haven't even done the part categories and part colors and relationships between parts. And I won't. I'm going to stop there. I think you get the point that to really understand what's going on in your data, I think the tutorial for wow, I'm really spruiking GraphXR, but I think that the team there deserve it, and I've loved this. I was amazed. There's a little, I think they call it How to GraphXR, which is a little tutorial. It's like 1.5 hours, and then you know how to do these extractions and merges and all this goofery. And to be honest, I know like 30% of what I should. In fact, you know what? For any of you who might want to goof around with this, I am going to save this snapshot, download the snapshots, and I'm going to take that and let's create a new folder here, and let's call it viz, right? And then take that downloaded file, plonk it in here. We'll just abbreviate this to LOTR, right? Lord of the Rings. Good. So now, if anybody wants to, they've got the little snapshot of this that you can literally, what happens if you're just starting blank and you're kind of like new and you want to goof around with something, you grab your snapshot, you just drag it in. You just drag that file in. And then it says, hey, there's a whole bunch of snapshots saved here. Which would you like? You guys can see some of my prior snapshots here too. And then that's it. And the most recent one pops up. So now you've got Barney the dinosaur's eyes popped out his head for you to play with. Okay, great. So thank you very much, GraphXR. We're now going to just return to what all did we learn. So here's what we know, right? Relationships of aggregation and composition we've already covered. There's only one other type of relationship, and that is that of association, right? Simply parts and colors are associated. A part is actually just an idea in the Lego universe. A part without a color is an unrealized thing. You can't go and buy a part that doesn't have a color, right? It has to be rendered into some color or it doesn't exist in the universe. Part categories are absolutely not the same. They're just another, see, little open-headed diamond, they're just another aggregation. Which brings us to Legolas Greenleaf, right? The minifigs. So I made a mistake, which I'm going to confess more robustly to in the final video at the very end of this video series, which will be the mea culpa video where I tell you about all my mistakes and screw-ups, and hopefully that'll be instructive. But I made a big mistake, and it was a mistake not doing the work that I've shown you in this video more thoroughly earlier on. In the early parts of rehearsal, I treated minifigs like parts. I knew full well that minifigs have got their own inventories, and that, in that sense, they feel very much like a set, right? There's this thing called the minifig, has its inventory, inventories have their parts, right? But they're also on other sets. I mean, they are components on inventories themselves, and then on and on and on. And I blinked, and I didn't think about it, and I ended up with a model. I'll show you just a quick sneak peek of that code. This is an example from the discard pile, right? When I'm in development mode, I use these various syntactical cascades to remind me of what I'm doing and stuff. So just don't worry about the weirdness of this code that you're looking at. This is the ample model that was discarded because I noticed I was doing this thing. Sets and figs, wherever they occurred, had this interesting rhyme to them. That whatever happened to the sets happened to the figs, kind of all the way down, right? And that's okay to a degree, except when you come to, constraint implementation. And anyway, I won't skip ahead to the actual model formulation too much here, but minifigs actually are much more like sets than like parts, and I'm sure you, dear viewer, would be able to tell me that, and I'm a dummy, and it took me too long to figure that out, right? Except, #just saying, the thing other than my own stupidity that helped me beautifully make this mistake was Rebrickable's schema diagram. Specifically, the lack of one line, okay? Here, check this out. Sets are related to inventories twice. Once directly, like this set has that inventory, and then once via this junction table, this inventory has other sets on it, right? But minifigs are only ever related to it once. On this inventory are a bunch of minifigs, right? But of course, minifigs have to have somehow inventories of their own, right? Like, because Legolas he's got his own inventory. So how does he have an inventory if the schema doesn't say that he can have one? Well, it turns out that they cheated just in a very, very sensible way. So the inventories table, which I'll point out the incriminating header, set number, and then, the first good few thousand records maybe are all just sets, except that I can also find Legolas here, way down the list. Him and all his cousins, aunties, uncles, nephews, all the minifigs are on this as well. That's how minifigs have their own inventories. They've had their names smuggled in under the rubric of set number, which is very, very telling. Had I noticed that before, had I done this exercise, which is to convert a schema diagram into an entity relationship diagram, had I done that a little bit more thoroughly rather than just being such a rock star and rushing it, I'd have figured that out sooner, and it would have been much more apparent to me that minifigs are indeed a type of set. So the other thing I have to say is that using a whiteboarding tool like this is really great, because then you literally have to decide, like, I wonder, am I going to line up the minifigs under sets? Because then you see that their inventories is kind of in line with their parts and stuff like that. And I'm happy to leave it where it is now, but I would have had to think about it. So it's an incredibly valuable exercise. Just do a good old whiteboard. Smash this out. You can also show your team. You look so fancy, right? And now we're almost done, right? We have a couple of extra items on our exploration docket, but really they're just items of documentation because we've already collided with these things. Let's jump straight in. We want to identify relational circularities. Here, sets via inventories can contain parts and minifigs, but also sets can contain other sets, right? This is the Scooby-Doo collection, and in this collection are these sets here, and then obviously those sets have their own inventories with parts and stuff. But what if these sets had other sets on their inventories, and on down? That hierarchy of sets nested within sets is present in some of the data, right? Some of the hierarchies are actually quite impressively long. How do we communicate that to the user? Do we want the user to assume that a collection like this Scooby-Doo collection will be flattened, right? So it just doesn't matter how many nestings down, we're just going to present this collection as one inventory. I think no, it's totally technically possible. It's just not a great user experience because this collection, like, you're building different things, and it's just kind of a strange thing to say, oh, and they all have one inventory, right? Good. So we've resolved that. I have not found any other relational circularities that we need to worry about. Next, we want to nix entities not needed in the pursuit of our objective. And we already did. The only entity we're getting rid of was elements. And then we want to extract entities from fields on other entities if we find them useful. And I think that there is a field worth extracting into its own entity. It's here on the junction table between parts and other parts, which denotes part relationships, right? So parts relate to other parts, and there are 6 ways in which they do. And we know that because we go to this field, rel type, and we extract the unique things that it can be. We find just 6 things, and it would look like this. We would find mold variations, alternates, printed versions of something that's not printed, by default, and a pattern of it. Then you've got these things which are body parts of, which is basically like, hey, this left arm is a body part of like a torso or something like that. And that is interesting, but I've graded out. That's not the kind of relationship that we're going to care about. Same deal with pairs with. You could have like the upper and lower parts of a dinosaur's jaw. The two things pair with each other, but the upper and lower jaw don't look the same. They're not interchangeable. You couldn't use the upper jaw for the lower jaw. That's another reason why I'm not jamming with pairs with or with body part of. But now to Legolas. And in particular, Legolas's head. Let's have a little chat about how these relationships work, right? So Legolas's head is a unique head in the entire Lego universe, right? And it is related to other parts, but mainly heads, via these relationships. For example, it's a printed version of this plain head with a hollow stud. That plain head is a mold variation of another plain head that has a solid stud. That solid stud plain head has got many printed versions of, one of which is this head with mustache, stubble, and messy hair. So if we wanted to build Legolas, for example, but his head went missing, dog ate the head, then our optimization model needs to be able to traverse this network of relationships between parts and parts and parts, and maybe do 1 hop or maybe 2 hops or 3 hops or more to find, hopefully in the user's inventory, a part that is interchangeable for the one that we do need. Now I know, because you're thinking it and I'm thinking it, who is this head mustache with stubble and messy hair? Well, I've done the research. It is Frankie Poullain. Frankie Poullain is the bass player of, and this is true, the best goddamn rock band of our brave new millennium, The Darkness. Seen here exiting a Lotus Esprit, fine specimen of a vehicle, also available red, also available as a buildable My Own Creation set by user NV Carmox. Let's take a look. This is fantastic. This little set is awesome. NV Carmox, I don't know who you are, but I really love your style because you build cars with relatively few parts, and it's hard to render these very distinct and recognizable designs with like 349 parts. Take a look at some of the things. This, 1970 Challenger, of course, right? Ford Mustang just pops out at you here. The Peugeot Pikes Peak Challenger. NV Carmox, like, I'm paying you your €5 for sure once I have some time and some bricks. This is fantastic. And it does bring us to the final item on our exploration docket, which was really to note what we do not have in the data. And our first example is these missing My Own Creations. They're not downloadable, which is to say the inventories for them are not downloadable. That makes perfect sense. It might be quite impolite, given all the work that someone like NV Carmox has put into creating all these little custom sets, for the inventories of those sets. They don't amount to the design, the instructions for building them, but it's still the inventory, still tells quite a bit. Impolite for the folks at Rebrickable to share that with the universe. All we need to do in reaction to this missing data is to be extra sure that our mathematical program works really, really, really snappy, because there are a pile of these my own creations, right? That in the footer of the Rebrickable website, we can tell here 22,000 official sets. That's the data we have, and 121,000 my own creations. That's the data that we don't have. So we need to extra sweat the speed, which at some level was kind of the whole point for this series. It's something I'd like to get off my chest, all these little speeding nicks and tricks and who knows what, right? Good. But what else are we missing? Well, we are missing set and part prices. On the Rebrickable site, we can go to my parts and see here that each of them has got a little 8 cents and 7 cents and 22 cents and 15 cents and so forth. This pricing comes from somewhere. I don't really know where it comes from. I imagine it comes in from maybe officially the Lego group, or maybe via API from some of the second-hand marketplaces like Bricklink and Brickowl. And this is probably fluctuating data. Anyway, it's not downloadable, but we will need to fudge data like this. We won't do it right now, but when it comes time to associate data to specific sets and parts, we will make it up. And we're doing that so that we can implement an optional feature, which is the user could decide to spend a couple of extra dollars to purchase parts that would make up for interesting collections of these concurrently buildable sets, right? They don't have to, but they can. Good. What else is missing? Well, we're missing data about the user's parts, right? So my sets, my parts, and my minifigs. So as luck would have it, those are pretty easy to get on a per user basis. We're just going to use my sets and parts and minifigs for development. Here, click on the header here, the total part count. It takes you to your all parts page, and there's this great export dialog with many choices. We're going to calibrate on the Rebrickable CSV option so that in future, if anybody else wants to use this little gadget, then people can just bring their own CSVs. And we're going to take those and plonk them into our data folder. This is the one we just downloaded with my parts, right? Let's call it something sophisticated like user parts. And then let's do the same deal with sets, which are here. We can go to set list, my sets, and export sets in the Rebrickable format once more. Same deal. We've got our user sets. Minifigs, I think the export is not as straightforward, or just there's no export option. No big deal. Maybe I don't know where it is. I'm just going to take a little copy and paste them into a new text editor. Let's do some fancy multi-cursor business. Multi-cursor business. Speed kills. Actually, let's carry on with that idea. Let's call it fig num as a header and quantity. So those are the two. So we just create a little CSV right there, and let's save it into our CSV folder as userfigs.csv. Okay, good. We've got that there now, user figs, parts, and sets. There's one more element we need, which is the user's search preferences. We're not going to make them up right now. We're just going to allocate a space for them. But what I mean by that is if you go to the Rebrickable site, and you start using their build feature, and you start fiddling with options, right? Manipulating your color sensitivities and checking these little boxes and who knows what else. We need a place for this kind of session data to be it's not quite session data. Session data means something else to web developers, right? But for this one use type search data, just parameterizing the search, we need a place for that, because that is absolutely an input, a very critical input to our model. So, obviously, I'm going to not make that a CSV though. Let's create a new folder called flat, and that's going to be for flat files. And let's just go back to where we were goofing off here and create a new file, and I'll literally just call it something like user options, right? And it will save this file as something like user options, right? But .dat. It's going to be just a text file in the .dat data file format, which is something that Ample can ingest, pretty commonplace out there. And we're going to put that into the flat files folder. And now let's see. Yes, we have our little blank. We have done a tremendous job. All right, let's recap. So actually, it may seem like we did many things, but we did one thing and we did it quite well. We did this retranscription of the relational schema diagram that we got from the Rebrickable website. We've taken that, we've annotated it, we've extracted bits and pieces out of it. The major work we did was retranscribed into this entity relationship diagram, right? And that took a sweating of details, relationship for relationship, entity for entity. It was the careful traversal of the data and mapping it out bit by bit that led us to discover, for example, how the Rebrickable team are smuggling minifigs in with the sets really for certain data operations, which we absolutely will do. It led us to understand relationships the way that they intend it for part interchangeability. And then we met the best rock band of this new brave millennium. We then found our way to the My Own Creations universe, which is the real richness of the Lego communities online. And we realized that while we don't have the 121,000 something of those My Own Creation sets in our data, that's okay, because they'll arrive if we do a good enough job making this application such that the Rebrickable team might want to have it for themselves and let the community use it. So we do want to reward ourselves with a result now, because we do have a strong result. We've got a list of our optimization models entities, and that is the themes, sets, inventories, parts, colors, and relationship types, and part categories, right? Like cheese wedges, gears, what have you. Right? These are our entities that migrate into the optimization model. And you might say, well, that's almost all the entities we started with. That's true, but we've happily eliminated the headache of elements, which are like a really useful entity in the Lego world out there, just not for us. And we eliminated minifigs, but we didn't eliminate them like we're excluding them. What we did is we merged minifigs into the sets entity. And now that we've got a whole collection like this, let's give them fancy 4-letter names each. We're going to mark our tables in our schema with their little 4-letter names, so we know these 6 tables were the ones that migrated over. 7 actually counting the extraction here. And this huge focus that we had on like the types of relationships, this is the payoff for that, right? We know that we're going to snatch all 7 of these entities into our optimization model. Thank you very much. But these are the core entities: sets, inventories, parts, and colors. These are inseparable. The relationships were the clue, right? Sets, inventories, and parts, they're all related via these compositional relationships. And minifigs, we've smuggled our minifigs into sets. Thanks a lot, so we've got them. Parts and colors, they need each other. They're lovers, right? Can't separate them because you can't have a part that isn't rendered into a color. Woo! So we've done a bunch. Now let's grab our entities. Let's build this little model stub and commit it to GitHub and go to bed. So let's head over to our project folder. And here it is open in VS Code. Well, before we create the model, let's first commit all of our data so we can have separate commits. I'm a little bit of a stickler for that, right? So let's go git add, right? And let's do a little git status. Okay. This is all of our data shenaniganry. Except you know what? Got this annoying DS store. This is the Mac OS generated thing. I think it's because we don't yet have a git ignore. Okay, now we will. In our git ignore, we'll just do something like, let's see if that worked. Let's go git reset. Now git add, boom. Git status. Yeah, the DS store files have disappeared. We have our git ignore. Beautiful. Okay, so the reason I want to commit separately is that I just really want my commit message to be nice and clean as to what it is we did. And the first huge bit that we did was we added data. Boom. The next thing we'll do here is we'll say new file model.mod, and let's paste our little set entities, right? So let's make them real. These are now set declarations in ample. And just in case we forget, we should label them as sets, right? Now in the series ahead, I'm going to be talking about the 5 components of these optimization models. So I'm just going to label the 5. After sets, we have parameters, then variables, then some kind of an objective. And if we paste the objective from our whiteboard, it's something like this. Boom. Find the maximum number of sets concurrently buildable from my Lego parts. And in the ample language, it does indeed look something like maximize an arbitrary objective name, just let's call the name buildable sets. It will reserve the name in the namespace, so we can't have a variable or anything else called buildable sets exactly with that casing, but I think we can live without that. And that sums all of the sets in the set of sets. We're playing a language game now. I've been using the word entities all the way through this video to not use the word sets because it's confusing because we've got Lego sets. But you know, in these optimization models, the things, the entities, they're actually called sets. So we're just gonna have to deal with that. We're gonna sum all of those that are buildable. And we know that they're buildable because they each have a little variable against them, which will figure out the machinery of how to flip that variable into 1 or 0, a little binary, a little Boolean, if you will, a little binary variable called set buildable, because you know we need to call it something, right? So that's it. We just sum the number of buildable sets, and then we maximize that summation, and that's the objective. Great. And since we've got a little bonus here, we actually have this little variable. What we can do is add it to our variable section. Do you know what? Well done. For some reason, ample, even though I imagine compared to other languages, there's not a lot of ample code out in the GitHub universe and elsewhere online. For some reason, things like GitHub Copilot, they just eat it up. They get it. It's actually a very simple syntax. It doesn't have a lot of stuff compared to other stuff. And I have found, obviously, you don't let it do the math for you, right? But things like just, you know, completions, they're insane compared, for example, to Python, where they're like good, almost infallible with ample. Anyway, that's my 5 cents. Now, so we've got our sets, we've got a placeholder for parameters, we've actually got a variable as a bonus, we've got our objective, which will probably be our objective for a good long time, and then we've got a place for constraints, right? And since our objective kind of hints at a constraint that needs to exist here in this little, in brackets, this find the maximum number of concurrently buildable sets, but from my Lego parts. So we'll have to implement that later, not today. Each buildable set must have all of its parts accounted for. I'm happy with that as sort of a, now look at this, a suggestion on that. We're not even gonna go there. Okay, that's our start on our model for today. So let's commit that. Yep, just the one file, model. And let's call this something fancy like add model. Boom. Oh man, folks, this video almost killed me. I don't know how you're feeling on your side. If you're still here, you are a rock star. I love to meet you. In fact, you know, if you come this far, come a little further. Visit the Discord that's linked in the description below. It's kind of an experimental place. Don't really know exactly where it's going, but people are piling in, which I'm really grateful for. And maybe the beginnings of some interesting conversation here that just doesn't find a home someplace else online about optimization could occur. So you're very, very welcome. Also, go to the GitHub repository for all the cool stuff we've been doing here. Check out GraphXR and play with Barney's eyeballs, right? You've got the snapshots in the data directory now. The whimsical dashboard is here for you to geek out as well. I believe that if I just take the whimsical link and paste it in the description here and in the README on the GitHub repository, that you can access it. If anybody struggles to access it, please let me know. And with that, you guys are rock stars. Oh, but we forgot one thing. Git push. This video is dedicated to Dr. David M. Gay. Dave, you said before you start with anything, focus on the data structure. It's made all the difference. Thank you.